To maximize the value from Verizon acquisition of XO networks need to be onboarded on and managed from Verizon's Network Management Suite. Our team is responsible for migrating access circuits and permanent virtual circuits or PVC from XO database to the Verizon logical provisioning systems. This is a complex task which requires understanding of types of network devices, network topology, and differences in how the data is stored. The team started working on preparing the XO database for migration and configuring the Verizon logical provisioning systems. Few weeks into the implementation, we discovered critical issues in XO database and Verizon logical provisioning systems. We discovered that the data in the XO databases is not in sync with the live network data. Migration of data to the Verizon logical provisioning systems can be expected to have data mismatch. Some of the data required by Verizon logical provisioning systems is either insufficient or missing. This implies a 56% failure to support customer profile migration due to unavailability of data, significant failure in migration of records into the Verizon logical provisioning systems, incorrect information on capacity, resulting in loss of revenue, MACD failures leading to customer outage, significant increase in customer support tickets post-migration. This significantly changed the problem area and we went back to the drawing board. We came up with a hybrid approach to achieve the goals. The approach involves understanding how the actual network path exists, parsing the configuration data from each network device, stitching the network path based on the configuration of data, and migrating into the Verizon logical provisioning systems. The team is parsing and extracting the network configuration data, stitching the network path based on configuration data, and migrating the data into the provisioning system. In addition to this, we also ensured that the extraction of data is consistent. The team is now implementing the hybrid approach and has initiated parsing of device files and automated the parsing logic using Python to parse thousands of network configuration files, initiated the stitching of complete network path based on network configuration data and loading into the Verizon logical provisioning systems. After parsing of the PVC stitched path, the team has developed a tool to automate this process. The hybrid approach is showing encouraging results. We are focused on addressing additional key challenges like enhancement of network configuration parsing or NCP tool according to the different types of devices deployed in the network. The network devices are very comprehensive and require significant efforts for extracting the data. Data loaded in the provisioning system has inconsistent data about the XO network topology, which is being fixed. There are a number of network topologies which are present, and the team needs to parse each topology to validate the tool. This is critical to minimize the number of fallouts. Different topologies have several complexities like presence of ring topologies. The PVC stitching logic has to be enhanced to handle each of XO-specific scenarios. Lack of method to approximate how many PVCs corresponding to particular network topology are present, there are just ballpark estimates. While the teams are working on the identified issues, the hybrid approach has allowed them to deliver encouraging results in a short time. About 10,000 access circuits have been already loaded into Verizon's database within 3 weeks, and the team is completing PVC stitching topologies and migrating to the Verizon logical provisioning systems. The team is now working on wrapping up their work in the next few weeks. We are also working to stitch PVC path for remaining topologies and increase migration numbers as soon as the network configuration data is available. We are continuing to work on improving the overall data migration and integrity. This will enhance the overall customer experience for the XO customers after the transition.